curve C has the equation y equals x squared minus 5x plus 4. It cuts the x-axis at point L and M shown in the diagram above. Part A, find the coordinates of the point L and the point M. Well, I know at each of these points the y coordinate is equal to 0. So if I take the equation of the curve and make the y coordinate equal to 0, I can now factorise that to find the x coordinates. So it will be x minus 4, x minus 1. So therefore x is either equal to 4 or 1. So I think the x coordinate at point L is 1 and the x coordinate at point M must be 4. L is 1, 0. M is 4, 0. Part B says to show that the point N, 5, 4 lies on the curve C. So if it lies on the curve C, then I should be able to substitute it into the equation for C. So if I substitute x equals 5 into that, I should find that y is 4. So y equals 5 squared minus 5 times 5 plus 4, which is 25 minus 25 plus 4, which obviously does equal 4, which is what we wanted to show. So yes, the point N, 5, 4 is on the curve. Part C, we want to find the integral of x squared plus 5x plus 4 with respect to x. So we're going to add 1 to the power and divide by the new power. The 5x, we're going to add 1 to the power and divide by the new power. The 4 will integrate to be 4x, and don't forget your constant of integration, c. So that is my answer to part C. We're then told that the finite region R is bounded by the line LN, LM, and the curve as shown in figure 2. We need to use our answer to part C, so the integral, to find the exact value of the area. So we need to find the shaded area R. Now, the way I'm going to do this is if I draw a vertical line at point N, where the x coordinate is 5, if I integrate my curve, so if I use my answer from part C and integrate between 4 and 5, it's going to tell me the area between the curve and the x-axis here. So the integral between 4 and 5 of x squared minus 5x plus 4, that's going to be the yellow area. And notice, if I then take that away from this bigger triangle, so that big green triangle, take away the yellow area, would leave me with the shaded grey area. So that's my method. The integration we've already done, we did that in the previous question. We'll have 1/3 x cubed minus 5 over 2x squared plus 4x between 5 and 4. So we'll substitute the 5 in here. So 1/3 times 5 cubed minus 5 over 2 times 5 squared plus 4 times 5. We'll then substitute the 4 in and take them away. So when you do that, you find that that yellow area is 11 over 6. Right, what about the triangle now? Well, the base of that triangle is just going to be 4 because we know that the x-coordinate here was 5, the x-coordinate here was 1, so the difference between them is 4. This length here is 4. The height of the triangle is also 4 because it's the y-coordinate of point N. Therefore, the area is half times base times height, which is 8. So, if I now do the area of the triangle, 8, take away the yellow area, which is 11 over 6, we find that the shaded area R is 37 over 6. And that's my answer.